Okay, so last time we were in the middle of messing around with some timers, right? And we saw that when I put a display text inside the timer, remember display text is a persistent behavior. So the type of animal that is a persistent behavior, and I have this guy going a random amount of time. And let's actually go ahead and change this to 1 second for right now. So every 1 second, something's going to happen. We're going to increment the game clock, and then what are we going to do? We are going to show the game count and the random number associated with this particular, what do we call this guy? Flame turtle. Okay, so every flame turtle will generate their own random number and then have a timer associated with it. And every 1 second, something's going to happen. We'll increment the game's count, and then we'll display some text. And if you remember at the end of class, we saw this behavior where now we're getting the flickering. Okay, so we are getting stuff flickering on the screen, which tells us what? It tells us that this display text is only happening as long as this timer was firing. And when the timer finishes its round, this behavior dies. Okay, so this was inside of a this is inside of a container. Timers are of type container. Let's go down to timer here. So it's a behavior container. So this guy holds behaviors, and at the end of what the timer says it should happen, any behaviors that are in there go away. All right? Let's actually go back in here. So if we want the flicker, we know we can make it happen in here because this is pulsing that display text thing over and over again. Otherwise, if I move display text outside of our timer, so now our timer looks like this. Actually, I think I have some bad syntax in here. I think these are supposed to be 2 dots. I'll explain that in a second. Oh, still not 2 dots, but now we see it's not flickering. Let me actually... Well, actually, I think that might have been the problem. Now I think we're... There we go. Okay, so each of these guys, I'll explain what those 2 dots were here in a second. But each of these guys we see has a different random number. This one is an 8, this one is a 2, and they're both showing the current count. And count is updating, but we're seeing count update at the same time. Okay? And this actually has to do with how threads work. This character, this flame turtle character, he is going to, well, once we put him onto the screen, he's going to be associated with some threads. Well, at least one thread. And a thread is what allows more than one thing to seemingly happen at the same time. So every single time we create a new copy of our flame turtle and we put him out here on the screen, this guy's going to have a counter, this guy's going to have a counter. Now, we look at these counters as operating independently, but we see that whenever text is being displayed, that text is being displayed simultaneously to both of these. Now, what we're going to do is we're going to change we're going to change our random number inside of our flame turtle. So right off the bat, we set it to a random number between 1 and 10. I'm going to go ahead and do that inside of our flame turtle as well. So our flame turtle is going to increment the count and also set a new random number. Fine. And then we'll display the text. So the initial version of display text, which we could even put up here, is fine before the timer. This guy's going to show the current version of game count and our current rand. Now notice we have a variable here called count, and it's owned by the game. That guy exists one time. So game dot tells us that we're using that count variable. But this variable, this attribute called myRand, is actually owned by self. Self is a local variable that is how this instance of flame turtle refers to himself. Not all flame turtles, just this particular flame turtle. Okay? That's why it says self.myRand. So we'd expect to get a different random number for each of these guys. So we'll initially set it for some random between 1 and 10, and hopefully they're not the same number. But we're doing it every single time through our timer again, so I think we're going to start seeing some differences regardless. We'd have to have some pretty stellar luck to always generate the same random number. And then we're going to display our text, but the display text is happening outside of the timer, so we won't get the flicker because it's not associated with a container that dies at the end. So we'll go ahead and run this, and hopefully every second we see that the game's count is staying consistent. But we see that the random value, which is owned by each individual instance of Flame Turtle, is changing. Right? There is a thread of execution that is happening inside of this timer. So when this timer starts, a thread is created. And that thread will increment the game count and increment this guy's random number. Now, let me think how I want to prove this. Okay. The question here is the timer for this flame turtle and the timer for this flame turtle, are they happening in the same thread or different threads? What we are seeing happen is, since it's always jumping by 2, right? The count, which means that each of these guys has incremented the game's count by 1. So we're never seeing a situation where one of them goes up by 1 and the other one goes up by 2. They're always jumping by 2. Make sense? Similarly, we're seeing that our text is always updating at the exact same time for these guys. It actually probably isn't the exact same time. They're probably sequential, but it's happening so quickly it seems like it's happening at the exact same time. So the question is, do each of these get their own thread? Or are all timers, at least at this point, associated with flame turtles happening inside of a single thread? If each of these guys got their own thread, wouldn't it be possible for this guy to finish doing his thing and display text before the other guy got his timer and did something? It seems like it'd be possible, right? So we're going to throw a little curveball on this. I'm going to throw a timer out here. And this timer is going to fire after some amount of time. Okay? So this is almost like a delay. So we'll call this guy delay. So we're going to use our timer to delay the game for some amount of time. And just to make this a little bit more random, I'm going to say we're going to delay, here's our functions, random 1 to 10. All right, so that's what this container does. I'm going to drag our other timer inside of our delay timer. So after a random amount of time between 1 and 10 seconds for each of our flame turtles, this timer is going to fire. This after thing happens exactly one time. Okay? This is a one-time delay of some random amount of time between 1 and 10 seconds. This timer is persistent. Just keeps happening. Okay? Because this guy actually never finishes, because it has an unlimited timer inside of it. So this guy never runs to completion. So now what we should see is and actually let me go ahead and move our display text inside here. That's good enough. So after some number of seconds between 1 and 10, this particular instance of Flame Turtle will display some text and then start running a timer every 1 second. Okay? So we're hoping that each of these guys starts on a different start time. Okay? In fact, actually, we can... I think we can show it. I set my rand, so rather than this guy waiting, doing a random number right there, I'm going to actually have him get the Flame Turtles, my rand. The random number we set. Okay, now this delay only happens once, so we don't have to worry about the fact that we're changing my rand inside of here. So then what I'm going to do is outside well, let's just drag the whole thing out here for right now. I'll display the text, and then our delay is going to happen. So we want to see what behavior this is going to give us. Generate a random number between 1 and 10. Display the same thing we showed before. After that random amount of time, this guy will fire. And what will happen is every 1 second, we're going to update these two variables. Okay, we want to see the behavior that that gives us. All right, well, there we go. we rolled the dice and both of them had 9 seconds. So after 7 seconds, this guy's going to do something. After 6 seconds, this guy's going to do something. Now notice what's happened here. Are they updating at the same time? They are. Let's run it again. This guy's going to happen pretty quick. We delayed 2 seconds, but both of those guys, let's watch that again. After 2 seconds, this guy should have already fired, right? But not until 7 seconds did they both start cooking. Does that make sense? What does that tell us? That says that there's a single thread of execution that governs all Flame Turtles. At the very least, all Flame Turtles. We might even speculate it governs all the things on the screen. Okay, let's see if that's the case. Will text show up on Mario? Let's see if we can get a little text on Mario. So we'll just do a display text. It's in white. Let's display the games count. That'll be good enough. And then I'm going to go ahead and throw a timer here in Mario to happen every 1 second. And what are we going to do in here? We're going to change the game's count attribute by 1. So we have 3 separate timers, each modifying this global variable that's the game's count. So modify games count to whatever it currently is, plus 1. Okay, so this is all the Marios. So all the Marios will always display the current count. Hopefully it'll be somewhere here in their little blue belly. And every 1 second, count will update. So we have 3 different timers, well in this case 4 different timers, because we have 2 Marios on the screen, right? So, I've lost my mouse. All right, got it back. So each of these guys has a timer. Each of these guys has a timer. They're all updating the game's count attribute. These guys are firing on a delay of some random amount that each of these generates, and we've proven that that number comes up random for each of them. So we have a different random number here than we have here, at least most of the time. Mario doesn't have anything to do with random, and we want to see whether the text updates at a different speed between all of these. Okay, because Mario's timer is starting immediately, right? Okay, actually, that was a really good example. Right off the bat, notice what's happening here. The display text on these guys is updating even though they haven't fired yet. Why? Because Mario is changing the count. He's changing the global count. So every single time that global attribute updates, the display texts associated with it update. Okay? So we see that much. Now something we should still be seeing here is notice that after they've all gotten into sync, everything's firing at the same time. So it's almost like we have this global thread, i.e. the game clock, that when we say something needs to happen, we toss it into the game loop. Okay, and the game loop keeps all this stuff happening. So once each of these timers have fired, they all get thrown into this game loop. And updates in the game loop happen at a consistent rate. I want to make one more change here. Go back into our flame turtle. And instead of displaying the text outside of our timer, we're going to go ahead and display the text inside of our delay. Okay? So right now, the text associated with our flame turtles will not actually display until after the delay has occurred. So it'll display, which is a persistent behavior, and then the timer fires. So we run this. They have nothing. Mario's already cooking. This guy's kicked in. This guy has not hit his delay yet, right? Before we were tricked into thinking maybe he did, because he had text that was changing constantly. So what we've shown here is each of these guys is joining. Oh, they were both 2 seconds. That was a bad example. So these guys are already in the game loop. This guy's now in the game loop, all updating at the same time. This guy's now in the game loop, all updating at the same time. So when that timer fires, it gets added to this global game loop. Does that make sense? So when we're solving our problems, we have to keep that in mind in terms of the behavior that's going to happen on the screen. That's for displaying text. Now, let's say that instead of displaying text for our flame turtles, and just so we know when they're going to take off, I'm going to drag the display text back out of here. So we'll know the amount of time. And we're going to say after some random amount of time, instead of having this timer that does something in here, we're going to go ahead and just change an attribute. And we're going to change this particular guy's, so this flame turtle's motion, linear velocity on X to 100. So after a random amount of time between 1 and 10 seconds, the turtle's going to start cooking. It's going to start running. It won't look like running. It'll look like he's sliding because it doesn't look like a turtle yet. All right? And we're going to see that these guys do act independently. So Mario's going to do what he currently did. He just sits there and counts. These two guys are going to, actually, we do display the text, so that text will be updating. I display the text outside of it now, right, don't I? Yeah, so this is going to happen. So we'll see the text right off the bat on the flame turtles, and every single time Mario updates the accounts, we will see this update as well. So our turtles will look kind of alive right off the bat, and then after a delay, they'll start running. Okay, so after 5 seconds, this guy's going to go. After 6 seconds, this guy's going to go. All right, so independent timers, but all in the game loop. That makes sense? And the game loop says, do this, then this, then this, then this, then this, then this. Now do it again. Okay? That's why everything synchronizes up. Kind of make sense? Okay, so we've seen, this is again getting back to this idea of the matrix. This is the matrix of game salad. We have to understand that world that game salad, that the rules of the world that game salad lives in. All right. So let's get rid of these guys. And I'm actually going to create another actor so we can always come back to those guys here in a little bit. And let's see. We probably want to get... We always want nice graphics, right? Oh, this was a funny thing. I read this in class the other day. This was an Onion article. Nitro expected to win the Westminster dogfight. So talks about how they expect him to rip through the toy category, and you know, it's actually kind of cruel later on in it, but it is funny. All right, so we're gonna say smiley face. We'll go to images. Let's see. Oh yeah, this is a good one, right? Well, that one might be hard to cut out a little bit. Nah, it'd be fine. That'll be fine. All right, so I'm going to view the image. Oh, yeah. Okay, we're going to save this to downloads. Now, when I give you your homework assignment, you can choose any image you like. Okay, so I'm going to go to our, here's my toolbox. So on a Mac, you just open this up in Preview. On a PC, you'd probably open it up in Paint. And somewhere in there, there'll be this magic wand thing that allows you to just get rid of all the surrounding stuff. This was originally in a JPEG, which does not allow for transparency, so PNG does. So that'll allow me to make that transparent. All right, so I made that picture. I'll go ahead and save it. We're going to use a much smaller version of it. How big is this guy in the first place? 12 inches. All right. Well, for our game, we only need him to be maybe, let's go 2 by 2. Well, this keeps the proportional scale, so roughly 2 by 2. Save it again. We may actually make it smaller than that, but no bigger than that. All right, so now we'll go back in here. We're going to go to our images, and we're going to go ahead and import that image, and I had it in my downloads. And here's my evil smiley face PNG. All right, and we will go ahead and drag it onto that actor. Okay, and this guy's just going to be called Smiley. All right, so we'll see what smileys look like on the screen. All right, probably a little bit bigger than we want it to be, so let me come in here. We're going to change the size up here. So let's make it half that size. So we'll make it 74. 72. Oh, I should have been able to do that math. Good enough. Okay, so now Game Salad's starting to struggle a little bit. Okay, we'll say that's a little bit better size. All right, so that's the size of our smiley face. Now, what we're going to do is we're going to make a game. How many of you have ever heard of the game Whack-A-Mole? Okay. Do they still have that in arcades, or is it now just kind of like actually, do they still have arcades? How many of you have ever played the real Whack-A-Mole game where you actually have like the padded hammer thing and you're just... Man, when I was a kid, I played that at Chuck E. Cheese. And I'd go and crawling under the little cheese maze thing under the stage. Like to see me fit in that now. Get the jaws of life to get me out of there. All right. Do they still have Chuck E. Cheese's?
Yeah.
Still exist? Man. That was like the place to have a birthday party when you were a kid. And then my dad was a dentist, so Chuck E. Cheese used to show up to like our school and give us teeth brushing, like how to brush your teeth demos. And I thought it was cool that my dad knew Chuck E. Cheese. I still think it's cool. All right, what am I doing? Okay, whack-a-mole, that's right. So what we want to do is we want to have these guys show up on the screen at some random rate. Okay? And we'll start with one on the screen. And what we want to do is we're going to add a rule. Just to make sure that we can hit the smiley face. So we're doing whack a smiley face, I guess. So we're going to go ahead and create a rule. This actor receives an event, mouse button down. Actually, that's not the event we want. Mouse button down would respond globally. Let me show you what that means. It's actually a good opportunity to show a behavior. So when that happens, we're going to go ahead and destroy this guy. All right, whenever the mouse button is hit down. All right, we'll put a couple more of these guys out here on the screen. Go ahead and run this. Okay, and it's like from the Avengers, the Thor guy. Just boom, everything got destroyed because I pushed the mouse button down. I didn't have to actually click on them. Just mouse button, they all receive that event, they're all dead. We'd prefer for me to have to click on one of these guys and he would just disappear, right? That's kind of the game we want to play here. So we need to modify that rule for our smileys. Okay, so the event we want to work with here is the event that's called touch. Okay, so touch, and let's see, I think we can say touch inside will receive the, that'll work. So now, if we touch inside the actor, so somewhere inside what's called the hitbox of this actor, which is actually probably a square, so if we clicked like here, it would probably count, but that's okay for right now. Then we're going to have this actor get destroyed. And similarly, if we click out here, we're not getting them, right? Okay, now, so our guys are properly being killed now, right? Okay. We want to get these off the screen. Now what we want to do is we want to have these guys randomly pop onto the screen, right? So that means something has to spawn these actors. So what we're going to do is we're going to create another actor. And I'm actually going to just name this guy the Observer. Okay? And we'll drag the Observer out on the screen. We'll shrink him down a bunch. We'll actually eventually probably make him invisible. But right now we can find him on the screen. So this is the Observer. And what the Observer is going to do is he's going to have a timer. And we'll start off by just having this happen every 1 second. Every 1 second, what are we going to do? Well, we're going to look through our behaviors, and we have a behavior here called spawn actor. The actor we're going to spawn is a smiley, and we can choose where in the layer we want it to spawn. So we'll always say in front of the actor. That's in front of ourselves. So if I'm the observer, I'm spawning a smiley in front of me in terms of the layers on the screen. And then I can have it directionally happen. So I'm always going to have it happen to my left. And this is going to be at an offset position relative. You can choose relative to the scene or relative to the actor. So I'm going to say relative to me. So if I'm the observer, I want it to be to my left. And we'll start this off at negative 100. I think 100. That'll make it go down. pretty certain. So now the observer has a job to do. His job is to start spawning smileys on the screen. Come on, you got this. Oh, I went the wrong direction. You know, I'm going to get rid of our flame turtle and our, because I think they're slowing things down, because we have a lot of crap in there. Okay. And actually, just for sanity's sake, let me go ahead and reopen Game Salad. All right. So we need to fix up our observer. So it must be that this guy is 100 that way. Well, no, we had it right. So this would be, let's do negative 400 to the left, but the 100 should have been negative. Well, let's do negative 400. That should be over and down. It should be somewhere over here. No. Did I just luck out with the positives? Where is it spawning? Let's keep that neutral. Oh my gosh. Okay, so that was negative 400 there. So if I want to go down a little bit, so let's do negative 300, negative 100. There we go. Okay. And he is rotated, which is kind of disturbing. Oh, because that's the direction that he's going to be facing. I think that's the problem. Now he won't be rotated. There we go. So the direction is how we're facing this dude. All right, so every 1 second we got a whole bunch of these guys. So if I click on it, actually, oh, there, he came back. I just killed off multiple in a single swoop. All right, so now we want these guys to show up on the screen, but we'd probably like them to show up in some different places, right? So instead of position at negative 300, let's do a random position. Between negative 400 and negative 200. And then also a random position between negative 25 and negative 200. All right, so we got these guys showing up on the screen, and I can start killing them off. Okay, so cool enough, we can keep score. So maybe we keep score, so every single time we kill one, we have an ongoing score up here on the screen, right? And maybe that can even be our observer, since that's our scoreboard. So we'll go ahead and we'll just make this guy a little bit bigger. And then we'll have our, actually we need to set an attribute for our game. Gains attribute, no, we'll just use count. It's already there, starts off at 0. So every single time a smiley is destroyed, when this rule happens, we're going to change our games count to whatever it currently is, plus 1, actually. Whatever it currently is, there we go, plus 1. Okay? Now we're going to have our observer always display the text. Of our games count. And we'll have a display in black. Now, right now it's just going to be a solid number that'll show up on there. So it's 0, now it's 1, 2, 3. Okay, so we see what's happening. We probably want this to say score, right? Maybe score is 5. And that deals with something called string concatenation. Concatenation. Gluing, is that how you spell gluing, or is there an E in there? Let's just say it's good enough. Gluing multiple things together into a single string. In Game Salad, the concatenation operator is 2 periods. So for example, the number 5 concatenated with hello would produce for us 5 hello. Glue them together like that. Okay? So what we're going to do is, for our display text, we're going to say score, maybe followed by a colon and a space, then whatever the current count is. So in our observer, here's our game count. But before that, we're going to go ahead and say, I need to say score. And you need to put it in double quotes to make it be a string. Colon, space. Actually, I don't think there's a way to put a space in. It's like a weird Game Salad thing. That's fine. There'll just be no space for this little example. There might be a way for us to fake it. Actually, there is a way for us to fake it. We'll talk about that in a second. Oh, I forgot to put the dots. Two dots between it. So I'm going to take this string, concatenate onto it, that count. So our observer shows the score. Let's see if it's big enough for double digits. Okay, we're good. All right. So, obviously an awesome game. Probably can charge 99 cents for it. Somebody would probably buy it for 99 cents. You got some kid who's using their parents' credit card, would probably buy it. All right. Now, this seems kind of neat for about 2 seconds. But what would be better is if our smileys could move. It's harder to hit a moving target than a static target, right? So what we want to do is we want to make our smileys zip around on the screen. So right now we have this rule that if they get touched, they should get destroyed. So this is should I die. That's the should I die rule. Okay? But we're going to go ahead and we're going to set a timer up. And we're going to say every 2 seconds. Actually, let's say every 1 second. It'll feel zippier. Every 1 second, we are going to let's see, accelerate. Gotta choose a direction. So this is So we're going to do a random number between 0 and 270 for direction. And we'll accelerate at a speed of 200 relative to the current actor. So every 1 second, every one of our smileys is just going to start zipping in a random direction. Let's see what this looks like. Oh, he's not going very fast. I gotta juice it. Oh, because it's accelerating. This is a cumulative thing, so I probably need to make it about 20,000 to begin with. Now some of those are going to come back. I'm confident. Perhaps not. All right. I don't want to use accelerate. Accelerate was a bad decision. We're going to change the velocity. So we'll change attribute. Smileys, motion, linear velocity on X to be a random number between let's say 50 and 250. And we're going to do the same thing on linear velocity on Y. Motion, linear velocity on Y, random 50 to 250. All right, so hopefully after they come into existence, they start zipping around. Some of these guys should come back eventually. Oh, actually, they're always going to be positive, so it's yeah, I need to give it a range that contains negative numbers as well. Let's do negative 250 to positive 250. So sometimes they're not going to move very fast. So they're sneaking back on. Oh, got him. Oh man, totally awesome game now. Okay. So, for your homework, you were to create your own whack-a-mole game similar to this. You can choose how you want to keep score. You can choose how they move. You should choose your own. What you're hitting. So he doesn't have to be the mean face like this. Oh man, see, I'm not playing very much now. They're all getting away. So in any case, that's due on Monday. So create your own game. What I want you to submit is a couple of screenshots, and I'll put it on. I'll put this on Angel. But I want you to take a picture of your game running like this, or a screenshot of this. I also want you to show me your, smiley or your mole, whatever you call them, this guy's rules. Okay? And then lastly, I want a picture of your observer's rules. Okay, you can either submit this as 3 different screenshots, or if you want to put them all into a Word document, that's fine. Doesn't matter to me. But submit 3 images. Make sense? Well, at least 3 images. If you want to. My experience has been that some of you will get really into this and make something significantly more complex than what I made. And if you want to show it off, feel free to do that. And if you think it's really cool and you want to show it off in class, let me know. We've had some pretty funny ones in the past. All right, I will see everybody on Monday.